All right. Just, I won't do this one, but what's the fifth root of 1 plus I? What is it trying to say to do? Can you tell me how I'm going to write this mathematically?
Zn equals 1 plus I.
Z,
Z
to the
power.
5 equals
Yeah.
1 plus I. And then what needs to happen to this 1 plus I?
Polar form.
Polar form, mod arg form, good, which becomes root 2 cis pi on 4. I said I wasn't going to do it, but it looks like I'm almost done, so I might as well. What does r equal to and what does theta equal to? You mean r equals to a to the power of 1 on n, and then theta equals to 2k pi plus phi over n. Good work, you have been studying. Root 2. 2 to the half, and then 1 on n, 1 on 5. And that becomes 2 to the power of 1 on 10. This one is 2k pi plus phi, which is pi on 4, on 5. For k equals 0, 1, 2, 3, and 4. And then to solve for z, it's just literally now r cis theta, r cis theta, r cis theta, r cis theta. 5 times. It's from starting from 0. Just keep that in mind. Okay? Rewatch this video if you need to and do the question again. All right. These are the ones we want to do. Omega. Probably the worst part of complex numbers is this. I think once students master vectors, because that's meant to be the harder one of complex numbers, then once people master that, they actually find vectors okay. It's this one here that's not. And the reason why this one here cannot be mastered very well is because in vectors, even though the questions are different, the concept's pretty much the same. This one here, the questions are different, the thinking can be very different as well. So just like, I don't know, if you guys remember in binomial, all of a sudden I'm like, you just got to sub in 1 to prove it. And we just subbed in 1. And then we're like, oh, just let x equal to 0 now. We'll just let x equal to 0. And then we proved it. So same thing with these. These ones here, you just got to do some random stuff sometimes. So I'll guide you through the most common ones that are in exams. So that means 9 out of 10 exams will have them. But that 1 out of 10, it's just going to be random. You can never predict it. So that's just going to be you and your creativity on the day. You might have to sub it in. You might have to do sum of roots, product of roots. You might have to do factorizing. You might divide z squared, like that first question that we saw, that solving. That's part of the game, right? Let's do this. Find the cube roots of unity. That just means solve for z cubed equals to 1. I think we can get these out. I'm just going to give you the answers. There should be 1, 2k pi. So then cis 2 pi on 3, and the other one would just be cis 4 pi on 3. Done. Those will be your 3 roots. If omega is a complex cube root of unity, that means what? If omega is a... Thank you. Prove this. Now, there was a few ways we did that. You can pick whatever method you like. Tell me. If you remember anything. No, incorrect. You got to prove. Prove. You're not solving. Be careful. You're actually proving this left-hand side becomes 0. That becomes, that's later on. No? Incorrect. So the 2 methods, let's just recall. There's a few. I think you might remember it when I do it like this, Stefan. Omega cubed minus 1 equals, open bracket, omega minus 1, close bracket, open bracket. Yeah, it rings a bell now. I said as long as we decrease it like that, you just factorize this, equals to 0, and that works all the time. And because just basic quadratics, basic equation rules, if we've got 2 brackets equal to 0, or we've got any number of brackets equal to 0, the answer is this. Yes? I just don't like it that much. I think a more powerful one is this one. more powerful. And that's something that you know the topic of. You said GPs and APs. So this is going up by common ratio. What's it going up by? You should know that. W. If it's going up by W, the formula for a sum of 3 terms for a geometric is A Rn minus 1 over R minus 1. So that becomes A, which is 1. Always choose 1. Don't choose W squared. Always increase, don't decrease. R is W, you said. How many terms do we have? What is W cubed equal to? What's 1 take away 1? I just think that's a bit better. That's the one you should do. So it doesn't matter if I said 1 plus W squared plus W cubed plus W4. That would be your answer there. Let's do double line. What do we change W to the power of 4 to? Yep, which becomes just what? Just W, good job. So, left-hand side. Rings a bell, right? Some of this? 1 minus W squared. 1 minus W. 1 minus W squared. Equals. Anyone remember what to do now? These two? Probably group them together. Yep. And then, do I expand? No? Yes. Crazy, right? How powerful the brain can be. Bang. Expand. 1 minus W squared minus W plus W cubed. What's minus W squared minus W equal to? Well, go back up here. Minus W squared, if you brought them over, equals to 1. As you know, you need to get, because you already have a 1 here, you've got a 1 here, you know this bit has to be a 1. Squared equals 9. Those are the easy ones to get. Even though very poorly done. No. W minus W squared minus W, this bit, this 2, becomes 1. No, because 1 plus W squared equals 0. So when I bring these two over to the left, to the right hand side, I get 1 equals negative W squared. Make sense? You sure? Okay. Right. All good? Okay, move on. And here, look, again, you know, show this. Otherwise, you just do the otherwise method if you want. It's just geometric, there's 5 terms. W to the power 5 equals to 1 already. Done. Easy? Easy. No, pick one of these geometric ones if there is any. No, locus. Okay. Vectors. I don't know if I've got any vectors like this here. I didn't think so. Done. Let's stop that recording.